Hello, assalamu alaikum. My name is Fakisha, and in this video, we will talk about different type of operators and how to use them in Verilog HDL codes using Quartus 15. So let's begin by making our file, new project. First, we will make use arithmetic operators and make a file of file with A. Here we will select Verilog HDL first. So here we have opened a new project. We will open to code Verilog HDL file. Okay. Here I will paste my code for arithmetic operators and change name to A as it's of the file. So after that, I will simulate my code. So here in this code, we have these variables A, B, C, D to G, and there's a 4-bit input variable of A and B, and there's 8-bit or the output variables. So the least significant figure in this is 0, and the highest is the 3, and over here it's 0, and the highest is 7. So this is the operation of multiplication. So this is a multiplication operator. This is the division operator, is addition operator, and this one is a subtraction operator, which will be used in this code. Um, so it's the simulation is running. So here, after our code has been compiled successfully 100%, we will see the circuit by locating node RTL viewer, and so here, as you can see, this is our circuit. There are two inputs A and B, and these are the operators that are being used: divide operator, addition operator, this is addition, multiplication, smart operator. So it has run successfully. Now we will uh, view the waveform. We're going in university program. Okay, here we will insert node bus, node finder at the list. Okay, so here we have to provide the input. So in A, our input is 12. So in binary, so we can insert in binary as well as in decimals, unsigned. Here are signed decimal, unsigned decimal, and but we will insert in binary. So 12 in binary is 1100. So press OK, and B is 3. So 3 in binary we have 0011. So press OK and we will run the simulation. Yes, and we will save it. So here we got the output. So we will see and compare the output that uh, when the C is A into B and it's 8-bit output. So here you can see it's an 8-bit output, and the A into B should be, that is 12 into 3 in binary, it should be 0 0 or 1 0 0 1 0 0. So here we have 0 0 1 0 0 and 1 0 0. So after division we got the 4, and 4 is 100, and these are the decimal zeros behind it. It's 4 actually in decimals, and binary it is this. And when they subtract from each other, is the output is 9. So here it is 9, and the last case is modulus relates 1. So this is 1 output. So this is successfully. We will move on to the next one. So here, the second type of operator we are going to discuss over here is logical operators. So there are actually three types of logical operators. That is and, or, and this not. So output, the output we get from these are also of three types. That is, one is 0, and the other is 1, and the third one is unknown, which will be we will get X on the output. So now we will run this code. So here our code has been successfully run. So we will first see that how this will work. So has A is 2, which means it's high, and B is 0, which means it's low input, and C is X, which is unknown. So when A and B will give us D, A and B are being multiplied, so the answer will be a low output, and when A or B will give us E. So they will add into each other, which means that when a high and low input adds together, it's a high input which is the result. And when we will get A is high, we have A high. So when we will get not of A, our answer will be a low output. So it will be 0. And when we will take A or C, which means it's an unknown, and this then A is known, which is a high value. The answer will be, so it will be 1. So in H, which is not of C, so our output will be unknown because this C is not unknown. So uh, from node finder we will see our circuit. I go to RTL viewer, and this is our circuit. So you can see the three inputs, and these are our outputs. So we will now move on to the where we can provide the inputs. Waveform, university program. Okay, here we will insert nodes, node finder, list, another here. Okay, so here I will apply input. We have 2 in the A, so we will give it 0 0 1 0, and it is B is 0 and C is unknown. So for unknown we will write X, and we will run simulation. So here you can see that the D output is 0, which should be 0, and the E, which is output is 1, which should be 1, and F is 0, and G is 1, and B is the unknown X. So all the outputs are correct. So we'll move to the next one. So here we have the third program for checking logical operators. So here we are using gamma, beta, and alpha as inputs and outputs. So we have one input that is beta and two outputs, and that is alpha 2 and gamma. So here we have beta, so not of beta we will get 1, and here we have alpha 2 or beta, so this gamma output we should also get 1. So we will check by running a simulation or code. So this is a bit one size, and the beta has 1 in its input. Oh, sorry, the beta value is 1 and it is also a 1-bit number. So here our code has run successfully. Now we will see the circuit from this code from RTL viewer. So this is the circuit. We'll move on to uh, university program. Here we will import the nodes. Okay, our input will be 0-bit. Choose a 0-bit, and so now we will run this and we'll see the outputs of the waveform. So it is that here we have the output of the simulation. So when we provided the 0-bit of in, we got maximum, that is 1 in the output of alpha and 1 in the output of gamma. So they are, as we discussed, there would be 1. So they are coming 1 over here. So we will move on to the next operator. So the next type of operator we are discussing over here is relational operator. So we have greater than, less than, greater than or equal to, less than or equal to. So they are the 4 types of relational operator. So if A will be less than B, so it evaluates to 1. It will evaluate to 1. And if A is greater than B, it should, and the left side will be more than the right side, and it will evaluate false. And if A is greater than or equal to, that is more than or equal to C, which is on the left side, right side, the answer will get will be 1, which means a high bit. And if D is less than or equal to A, less than or equal to A, it means it is to unknown, because D is an unknown X over here. So we will run this and see our outputs. So here our code has successfully run. So we will move on to the waveform to create the waveform. Okay, here we will insert the nodes. List nodes. Okay. Press OK. So now we have to provide the inputs. So A is high over here, so which is mean it's 2 over here. So we will put 2 in binary is 0010, and B is 5 over here. So we will insert 5 is 0101 0101. So it's 5. And C we have is 2 over here, and 2 is 2 in binary is same 0010, and the D is unknown, so it will be X. So we will run the simulation. So after our waveform is generated, we can see from here that we got the output as we predicted them. So the E will should came 1 as the B is greater than A, which means A is less than B. So it is 1, and F is 0 because A is greater than B. So F is 0, and G is A is greater than equal to C. So it is also 1. It's also true. So it was 1. So the last one was H, which means H is less than or equal to A, whereas H was the unknown. So we got an unknown in the answer. So we will moving on to the next one. So here I have the next one operator, which is equality operator. So these are actually um, four equality operators. So first one is equals to. With the double equality symbols we use equal to, and with this one exclamation mark and another equal sign, we show the logical inequality, and these three equal signs together shows the case equality, and a one exclamation mark with two equality signs give us case inequality also. So we will run this code and see. I forgot to change the name, so we'll stop this and run it again. So the main difference we have in logical operator and the case operator, case equality, is that in logical equality we do not see compare the unknowns in the input or any signal we give, but in the case equality or inequality we also compare the unknowns. So we have used to see what type of output these qualities give over here. So here our code has run successfully. Now we will go and check and confirm our outputs of waveform. So here we will be assigning the inputs. So the A is 0 0 0 1 0 0 0 1 0 0, that is 4. B is, we have B, which is 7, and 7 is 0 triple 1. After that we have C, and C is 0010. C is 0010. We have D. D is double D is 0, then the unknown X and 10. So this is D. Then we have E, and E is X 101, and F is X 01. So 01. So now we will run it, run the simulation. save it. So while running this, we forgot something, that the output entries were less than we assigned them. So G, H, I, J, and K are outputs. So now we will run this again. So here our code has compiled successfully. Now we will make a waveform. Uh, where node finder list, import them. Okay. So now I will give the inputs. So the input we have here is 0. It is 4. So it will 0 1 0 0, and it will be 7. So it will be 0 1 1 1 triple 1, and C will be C. So C is 0 0 1 0, and okay, the D we have is, so D we have is 0 x 1 0. Okay, and E we have is x 1 0 1. Okay, and F we have is double x 0 1. So we'll press OK, and now we will run this. Okay, press OK, save it. So here in output you can see that that G is 0. It should come 0, and it is 0, and O we have is, so is 1. So O should come 1. It's a high output. So whereas K and H would be unknown, here H is equal to X. So um, and J is 0. J is equivalent to 0. So this is run successfully. So now we will moving on to the next operator. So here is the next type of operator that we're going to discuss is bitwise operator. So in bitwise operator we have um, 5 types of operators, which is first one is this one, negation. This one denotes and. This is the OR operator. And this is Xor operator, and this is the XNOR operator. So these are the 5 operators which are known as bitwise operator. So they perform their function accordingly. So in this is negation. It actually uh, works like a negation one. That is a not one, a not gate. So there here we have four 4-bit inputs. The A is a 4-bit input of 1100. B is a 4-bit um, input, it is 0011, and C is also a 4-bit input 0101. So I got some error here. It will be n module error. I cancel one. Now let's see. So here our code has successfully compiled. So we will move on to the making of waveform. Okay, we will university program. Here we will insert the nodes, node finder, list. Okay, okay. So here we have three inputs. So which are A is 1100 and B we have is 0011 and the C we have is 0101. So here we have to see that either these operations through operator perform correctly or not. So we will touch on this. Okay, this is running. So here you can see it is run. So now we will compare it. I will minimize this one. Okay, so by comparing, so D is the negation of A, the not of A. So A was 1100, so it is 0011. So it is the opposite of A. And in E we had that A and C, which mean um, that A and C will multiply together, and A and C we have A is 1100 and C is 0101. So the output is 0100. It was 0100. The expected output is written over here, and this is the output we are getting after running this simulation. So the F was A or B. So A or B, um, A was 1100 and the B was 0011. So addition of these both bit by bit, so bitwise they are being added, so it is 1111. So the G, the fourth output was that B, X or C. So B we had 0011 and C is 0101. So the common in between them was 0110, so it is 0110. So the last one is XNOR, and A XNOR of C is A was 1100 and C was 0101, so it was also 0110. So it is right. So that was this from the bitwise operator. Now we'll move on to the next one. So the next one we are having is um, reduction operator. So in reduction operator we have and, NAND, or XNOR, and XNOR, XOR. So these are the reduction operator. So here we have 4-bit inputs and 4-bit outputs, and we are using A is 1111 and B is 0101 and C is 0011. So here we will check bit by bit and add them or perform other operators function over here. So in this case, when D is equal to, we say D is equal to and A in reduction operator, it means that bitwise and bitwise we multiply the inputs of A together, bits of together, like 1 and 1 and 1, which means these are performed and function. Bit one bit is performing the and function with the other bit. So these are the interbit operators. So and this or is means that that each element of each bit of these 4-bit operator is performing or operator with each other, like this 0 or 1 or 0 or 1. So and the next one that is the Xor operator. So every bit of this C, a variable, is performing a function with each other, this operation with each other. So we will see and simulate this. I will run this and compile. this code. So now our code has been compiled. We will move on to make the waveform. So here are our inputs, and our inputs are A is 1111. Okay, then B is 0101, and after that we have C. So C is 0011. So now we will simulate it. So here we got the output, and we will see. So for D we got the 1, which was as assumed that it would be 1, as we didn't, and the E is also 1, it was a related one, and the F is, that is XOR of B, is 0. So it was 0. So it has run successfully. Now we will move on to our next operator. So here the next type of operator we have is shift operator. So there are two shift operators. There's a left shift operator and a right shift operator. Here we have three variables, and one is the input and two are output, and all are 4-bit. So the input we are taking over here is 1010, which is a 4-bit input, and the output we are doing over here is B is equal to A is left shift operator to 1, which means that we will move 1 bit on the left side, and the bit that will be added to it on the from the right side will be a 0. A new bit will be added. So, and in the second case, where it will be a C, which is a right shift operator we're applying, and it will be added, it will move towards the right, which means on the left side we will add two 0 bits, which, like you can see over here, if 1010 is A, and we apply left shift operator, one left shift operator, it will move to the left, which means this 1 will be gone from this side, and a 0 from the right side will be added to it, so it will become 0100, like you can see over here is 0100. And in the second case, when we are applying a right shift operator, uh, and 2, we are moving 2 bits, so from it will move towards the right side, so this 10 from this will be eliminated from here, and two 00s will be added from the left side, so it will become 0010. So I have done the simulation waveform of it, and you can see from here that it is giving, when we are applying 1010, it's giving the same waveform of 0100 and 0010. So we're moving on towards the next operator. So the next type of operator we are having over here is concatenation operator. So in concatenation operator, what we do is we actually merge or add two bits, two inputs together. Like it's we use it like this. Its form is like two curly brackets we use, and a comma to separate between, to show that these two inputs are being concatenated together. So here you can see that B and C are two inputs, and B is a 2-bit input, and C is a 6-bit input, and E and D are two outputs of 4-bit. So we are having A over here. See, so A is a 1-bit, we are using 1, and B is 2-bit, we are using 0 0, and C is a 6-bit, we are using 1 0 0 1 0 1. So uh, in this first D case, when D is the output, we are concatenating A and B. So in A and B, uh, you can see that B is 0 0 and A is 1. So A is coming first. So 1 bit, or the first bit will be of A. So A and the second 2 bits will be of B. So it will 1 0 0. So as you can see over here, it is 1 0 0. We will make the waveform of it. Uh, our code is compiling. When it's done, we will show it over here. So, and the second case over here is the E output case. So in this, we are using 5 to 3, which means we're moving 3 to 5 the bit numbers. We're using these one, which are um, these one. Yes. mm, yeah, these are the bits 101. So 101 will be of the C input, and A will be 1 bit. So it will become 1011. So you can see over here it's becoming 1011. So 5 to 3, this one and this 1 bit are combining together to form this. Our compilation is done. We will make the waveform for it. So remove node finder. So the A is 1, B is 0 0 is fine, and C is 1 0 1 1. So it's 1 0 1 0 0 1. Okay, now I will simulate it, save it. So here you can see, after the waveform is done, you can see over here that the desired outputs are the same that we did. Okay, cross, minimize it first. Oh. So here, okay, Quartus. So here you can see that when the A is 1 bit 1, B is 0 0, C is this one. So the D is the desired that the one, it would be 1 0 0. So it is 1 0 0. As it is 4-bit number, so this 0 is coming extra. But in the E case, the E is the output. The output, our output is 4-bit, right? 1 0 1 1. So this is done for concatenation. We will moving towards our next one, operator. So in this case, this is all, in this case of operator, we are using replication. Replication means over here that we are multiplying or repeating any value again and again, any bit again and again. So you can see that. So over here, uh, the input is A, and the output we are using is a 4-bit C. So it's a 4-bit number C, and A is 1 bit, and if we are applying a 1 over here, and B is a 2-bit, that is 0 0. So in when we are assigning this is C, so it is becoming 4A, and which means we are repeating a bit, that A1 4 times. So this is a 1, in B we have 1, so it will become 4 times 1, that is 1 1 1 1. So we are compiling this code, and we will see its waveform. Now as our code is fully compiled, we will moving on towards the waveform. So we'll go in university program, press OK, insert the nodes, last, insert, OK. So here we will provide A as 1, not 0. So it's 1, now we will run it. Yes, save. So our desired output is the same that we calculated from here, which is 1 4 times, that is 1 1 1 1. So it is 1 1 1 1. So now we will moving on to our um, last waveform we have to make of the code. So this is our last program. In this we are using two operators. First one is this one, replication, which will generate if we will apply 1 to this is a single put A, so it will become C will become 1 1 1 1. And for D, we have, if for B we apply 0 1, so D will concatenate to 0 1 and 1 1 1 1 for C, and then we will come with 0 1. So for that we will compile this code. So after simulation, we have over here the waveform. We are applying 1 to the bit A input, we are applying 1, and the B we are providing 0 1. So you can see the C is the it is 1 1 1 1, and the concatenation is happening, which is making it 0 0 0 1, that is, and 1 1 1 1 1 0 1. So it is performed right, I think, and that was it from this lab. Thank you.